So we're going to continue talking about solving equations. You'll notice the top of your notes say solving equations. Well, we've been doing that since August, but this is going to be a new thing, a new variety of equations that we're going to solve. So I want you to look at this equation right here. This is going to be our first example. And I want you to tell me what's different about this equation from any of the other equations we've solved so far. Take a second to look at it. I want everybody to think about that. Every equation we've solved so far has had one variable in it, right? And our goal is to get that variable by itself. Well, this one has a variable in it, but it has it in two different places. So the difference between the equations we're doing today and the ones we've done in the past is that the variable is going to be in more than one place. Now, what is our goal when we're solving equations? What are we trying to do in the end? Trying to get the variable by itself. The tricky thing here is if the A is in two different places, here and here, it's going to be tough to get it by itself, right? Because we've got two different things there. We've got the A in two places. So how do I get an A by itself when it's in two different places? Okay, what do you think I can do? Okay, is that what you're going to say too, Kaylin? Yeah. All right, so first of all, we're going to circle variables just like we normally do. So we circle our A. In this case, by circling the A's, we see that we have the A in more than one place. Knowing that the A is in more than one place, what we're going to have to do to get it by itself is get it in one place first. That's the first thing we have to do. To get the A by itself, we can only have it in one place. All right? So we're going to circle the A's. We see it's in two different places. We know we're going to have to do something a little different. We're still going to draw our line through the equal sign. Whatever we do on one side, we have to do on the other. So if I change the value on one side, I have to change the value on the other side the same way. And then what do I get when I add 2a plus 3a? Kaylin? What is 2a plus 3a? 5a. So what we're doing here is what we call combining like terms. Does everybody see why the 2a and the 3a are like terms? So since the 2a and the 3a have the same variable, then they are like terms and we can combine them. And so we look at the coefficients. What are the coefficients? The numbers in front of the variable, right? So we look at the coefficients, and in this case we're going to add the coefficients because it's an addition. So we have 2 plus 3 is 5, and then the variable stays the same. All right, so 2a plus 3a is 5a. And then on the right side, since we didn't really change anything on the left, we just combined stuff, we don't have to change anything over here either. It's not like I added 2a to this side of the equation, or I added 3a to this side of the equation. This is the same thing as 5a. So I'm going to bring the same thing down here, which is negative 15. So when I combine like terms, I don't have to combine like terms on both sides, or I don't have to add something on both sides. I just combine the like terms on each side. Now what? See, a lot of people have finished solving the equation now because it's pretty easy, right? The a is in one place, so all I have to do to get the a by itself now is what? Divide by 5. So by dividing by 5, that's going to cancel that 5 out in front of the a and leaves the a by itself, right? And on the right side, negative 15 divided by 5 is?
Negative 3.
Negative 3. And so we get a equals negative 3. So the equations that we're going to see today are going to have two new things in them. They're going to have variables in different places, and that's the big thing. So they're going to have A's or B's or C's or whatever letter we're using for the variable. It's going to be in more than one place. What we're also going to see is, like what we saw in the opener, we're going to see parentheses with a number out front of the parentheses, where we're going to have to distribute. So the two new things that we're going to have to do, that we're going to have to simplify equations, is we're going to have to combine like terms and we're going to have to distribute and use the distributive property. All right, so when we're solving equations with the variable in more than one place, and notice it says on the same side. So in that first example, the 2a and the 3a were on the same side of the equation. They were both on the left side. If they were on different sides, then we're going to have to do something different, and that's going to be what we're doing next week. All right, so if we have the variable in more than one place on the same side, the first thing we need to do is simplify each side of the equation. And to simplify each side of the equation, there's two things we're going to have to do. What are they? I just told you. See if you're paying attention. We're going to have to combine like terms, and we're going to have to use the distributive property. We're actually going to distribute first. So we simplify each side of the equation by using the distributive property first wherever we can, and then we're going to combine like terms wherever we can. Once we have distributed and we've combined like terms, then the equation is going to look like the equations that we've already solved. In fact, most of the time it's just going to be a two-step equation now. So at this point, the next step is to solve as usual. To go back to the stuff that we were doing before and get the variable by itself by using the inverse operations in reverse order of the order of operations. So in example 2, we have 3b minus 6 plus 2b equals negative 26. So go ahead and write that down and let's talk about what we need to do. And we're just going to use those steps that you just wrote down. First step says simplify each side of the equation. The right side of the equation can't simplify, can it? Can we simplify negative 26 any more than it is? No. But the left side, there's some stuff I can simplify. So I'm going to start by circling my variable. In this case, I have variables, more than one, and they're both on the left side of the equation. So I can follow those steps that we just wrote down. And so I want to simplify that left side of the equation. I'm going to start by using the distributive property. Can I use the distributive property here? No, why not? Because there's no parentheses. Exactly. So since there's no parentheses, there's nothing to distribute. So then we're going to combine like terms. Are there any like terms here to combine? Yeah, the 3b and the 2b, right? Is this a positive 3b or negative 3b? That's positive. Is this positive or negative? Positive. They're both positive, so we're going to add. What is 3b plus 2b? 5b, okay. What about this minus 6 here? Should I subtract that from the 5?
No.
No? What should I do with that? Raquel? So since the negative 6 doesn't combine with anything, I'm just going to bring that down with the 5b, and so we have 5b minus 6 there. On the right side, there's nothing to simplify here. There's no like terms to simplify on the right side, so we're just going to bring that down also. It's important to remember when we're simplifying, we don't really have to follow the golden rule because we're not changing anything. We're not adding anything. We're not subtracting anything. We're just combining stuff. We're just simplifying stuff. All right. Now, to get the b by itself, I have to get rid of the 5 and the negative 6. Which one should I do first, Scott? Good. We're going to get rid of the 6 first, and we're going to add 6 on both sides. And so when I add those 6's, the 6's cancel each other out here, leaving what, Scott? What's left on the left side? The left side.
Oh, 5b.
Okay, and then on the right side, negative 26 plus 6. One's positive, one's negative, so we subtract. 26 minus 6 is 20. Is that going to be a positive 20 or a negative 20?
Negative.
Why?
Because the 26 is negative.
Yeah, the bigger number is negative. All right, now what? Okay, good. We need to get rid of that 5, so we're going to divide by 5. So we divide by 5 on both sides. The 5's cancel each other out, which leaves what on the left side, Zane? Left side, Zane.
Oh, me.
All right, and on the right side, negative 20 divided by positive 5 is negative 4. Once we simplify the left side in this case, we combine the like terms, then it's just an equation like we normally solve. So we get a two-step equation here where we just get rid of things in reverse order of operations. Same thing's going to happen here, except what are we going to have to do on this one? We're going to have to distribute on this one, right? So we want to get rid of parentheses, and we're going to have to distribute. Now let me ask this. Should I combine like terms first or should I distribute first? I should distribute first. If for no other reason, it's because that comes first in your notes. If you look at your notes, it says simplify each side and it tells you to distribute first. Now, the reason we don't want to combine like terms first is because this looks like a 1c here. There's nothing in front of it, so it looks like a 1c. But it's not really a 1c. Why not? Why is this not really 1c? Can anybody tell me? So since we have this 4 out front, in front of the parentheses, This 4 is going to be multiplied by that 1c. So it's actually going to be a what? It's going to be a 4c. So if we try to combine like terms first, then we're not going to get the 4 in front of the c. So we can't combine like terms until we get rid of parentheses. So we're going to get rid of the parentheses here by doing what? Distributive property, yeah. So we're going to distribute the 4 times the c and the 4 times the negative 3. Should I do the 4 times the negative 2c also? Why not? Yeah, the negative 2c is not in the parentheses. All right, so I'm going to distribute that 4. 4 times c is what? 4c. 4 times negative 3 is negative 12. And then anything that I didn't distribute, just going to bring it down. So I'm going to bring down the equal sign. I'm going to bring down the negative 6 on the left side, and I'm going to bring down that minus 2c on the right side. Now can I combine like terms? Yes. So what like terms do we have? Yeah, we've got that 4c and the minus 2c. That is a negative 2c, right? All right, so what is 4c minus 2c? 2c. And then anything that I don't combine, just bring it down. Can I combine the negative 6 with the negative 12? Why not? They're like terms. Yeah, they're on different sides of the equal sign. All right, so I cannot combine those because they're on different sides. I'm just going to bring those down. So negative 6 on the left, the negative 12 on the right. All right, so that's the first step. We distributed, got rid of the parentheses. We combined like terms. Now we need to solve as usual. What should we get rid of first? I don't see a plus 12 there. What should I get rid of first? The negative 12. And how do I get rid of the negative 12? By adding 12. All right, so we're going to add 12 on the left. We'll add 12 on the right to keep it balanced. And the 12s cancel over there. So what do we have on the right side here? 2c. And on the left side, negative 6 plus 12. It's a positive and negative, so we need to subtract, right? 12 minus 6 is that a positive 6 or negative 6? Because 12 is bigger, 12 is positive. Okay, and then to get the c by itself, I need to divide by 2. What do I get on the left side? What do I get on the right side? Next one. This one looks fun, doesn't it? All right, so we have the d in 2 different places. I see that when I circle the d's. I'm also going to draw my line, so I remember to do the same thing on both sides of the equation. And so what am I going to have to do first, since the d's in 2 different places? Can I combine those d's right now? No, because this one's in a parentheses, right? So I have to get rid of those parentheses first. And what am I going to do to get rid of those parentheses? I'm going to distribute, exactly. So I'm going to do 5 times d, which is what, Trevon? 5d, and then I'm going to do 5 times negative 2, which is 5 times negative 2. What's 5 times 2?
10, negative 10.
So that's going to be a negative 10. Okay, good. And then everything else, since everything else is outside of the parentheses, I'm just going to drop that all down, right? So I'm going to have my plus 6d and my minus 3 there. And then on the left side, I've got my 20. And then don't forget your equal sign. So we distributed both sides. Now what?
Combine the 5D plus 6D.
Okay, we need to combine our like terms. So we've got 5d and 6d. What other like terms do we have? Raquel? Yeah, we have that negative 10 and the negative 3. All right, so let's do the d's first. Trevon, what do we get when we combine the 5d and the 6d? Yep, 5 plus 6 is 11, so we get 11d for that. And then, Dorcale, what do we get when we combine that negative 10 and the negative 3? Good. Since they're both negative, we're going to add them together and get a bigger negative. So we get a minus 13 there. And then on the left side, since that 20 can't combine with anything, we'll just drop that down. Now what? Yeah, now we solve like we normally do. So we get rid of the minus 13 by adding 13. So add 13 to both sides. On that right side, the 13s will cancel, which leaves what? 11d. And on the left side, 20 plus 13 is 33. Divide by 11. And we get D equals 3.